prove by mathematical induction that 1 cube plus 2 cube plus 3 cube plus up to n cube is equals to 1 over 4 n square, n plus 1 square. So for n is a member of natural number. So now this is sum of cube of first n natural number. So we want to prove this by induction. So now step 1, remember we said we have 3 steps. So step 1, show that the given statement is true for n is equals to 1. So show that the given statement is true for n equals to 1. So left hand side is equals to, so that means first term 1 raised to power 3. So that is left hand side is equal to 1, because 1 raised to power 3 is 1 times 1 times 1. So now right hand side we have 1 over 4 n square, n plus 1 square. So 1 over 4 1 square, so that means n is 1. 1 plus 1 square. 1 over 4 1 brackets 2 raised to power 2. So 1 over 4 brackets 1, now 2 square is 4. So 4 cancel out 4. So everything is 1. So that means the left hand side is equals to the right hand side. So it is true for n is equals to 1. So that is step 1. Because it's true for n is 1, so you will now conclude, therefore the given statement is true for n is equals to 1. So we have proved the step 1. Now let's say step 2. Step 2. Assume that the given statement is true for n is equals to k. So I said in this step, just rewrite everything here, but change only n to k. So that means this will be 1 cube plus 2 cube plus 3 cube plus k cube equals 1 over 4 k square, k plus 1 square. So for k is a member of natural number. So if you have replaced that with k, then you conclude the given statement is true for n is equals to k. So that is step 2. Now step 3, that will do simple manipulation. Step 3, using the assumption made in step 2 above. So using the assumption made in step 2, show that the given statement is true for n is equals to k plus 1. So left hand side, we have 1 cube plus 2 cube plus 3 cube plus k plus 1 cube. That is, you write all this, then kn is now k plus 1. So that is k plus 1 cube. So now it is this same left hand side that you will now change. Just put brackets here in your next step. Just put brackets there in this same left hand side. So this will becomes 1 cube plus 2 cube plus 3 cube plus, then just put bracket, then plus k plus 1 raised to power 3. So the next step, so everything in this bracket you have to complete it. You know it's plus dot dot dot. So but if you look at your question, is plus up to plus n cube. So you are going to complete this one also to plus k cube. So that means what I have in that bracket will be 1 cube plus 2 cube plus 3 cube, then plus k cube. So you complete what you have here, then plus, so we have this next, so plus k plus 1 raised to power 3. So next step, everything inside this bracket now is like what you have here. So and the result is 1 over 4 n square into bracket n plus 1 square. So everything here now will be equals to 1 over 4 k square. So I will now replace it with k. So just look at the two is the same. This is the same thing as this. Just like n k cube is now n cube, and the result is this. So you will now write all this to be 1 over 4 k square, as in write all this to give us this results here. So that's our next step. So this will becomes so all this now is this result. Yeah. So that will be 1 over 4 k square k plus 1 square. So that is for all this. Then I have plus this next, plus k plus 1 everything raised to power 3, like that. Now, if you look at these two sides, I have k plus 1 here and I have k plus 1 here. It's common. That means k plus 1 square is common because I have 3 of it here. So, if k plus 1 square is common, then that is this is common. It will remain this here, 1 over 4. And this will go and it will remain k plus 1 here. So, that will be our next step. So, our next step. So, I have to. So next step, k plus 1 is common. So if k plus 1 is common, so this will becomes k plus 1 square. So that is common. Open a compound bracket. So it will remain 1 over 4k square. So that will be 1 over 4k square plus 2 of that one will go out. It will remain 1. It will remain k plus 1. So like that. Now here, if you remove this 1 over 4 out also, so that will be 1 over 4 k plus 1 square is equal to k plus 1 square, then open bracket. So if you remove this 1 over 4 out, then this will remain k square plus 4 brackets k plus 1. So that is 1 over 4 times 4. This 4 will go because this k plus 1 does not have 4. So if you now remove 1 over 4 out, you must put 4 there so that the 4 will cancel out. So because if you say 1 over 4 times this, it will give you this. 1 over 4 times this, so it will now give you this. So that's it. So now, the next step. Next step. So we are going to use this 4 to open this bracket. So we have all this. To avoid repetition, that's why I copy. So now this will becomes k square plus 4k plus 4. That is 4 times k, 4k, 4 times 1, 4. So like that. So what I have in this bracket is like quadratic equation. Now watch my video on quadratic equation. So you know how to factorize this. So here product is 1k square times 4k square. Sum is the middle number. So what are the two numbers we multiply? 2 times 2, 4. 2 plus 2, 4. So I'm replacing this 4k now with 2k plus 2k. So watch my video on factorization method of quadratic equation. So you will understand better. So next step. So factorize what you have in this bracket. So you need to jot everything so you can see step by step. So now, to factorize what I have in this bracket now, so we have k squared plus 2k plus 2k plus 4. So bracket it 2 2. So now what is common in each brackets? That will be our next step. So what is common in each bracket? So here k is common. So we have k plus 2. 2 is common in the second bracket. K plus 2. That is k is common here. Then 2 is common here. So you need to go and watch video on factorization if you don't understand my video on factorization. So that part will be clear because this is quadratic equation. So now k plus 2 is here. K plus 2 is also here. Take 1 out of the 2 is common. So take 1 out of the 2. So please remember there is power 3 there. Don't forget. I removed it before. So now this will be k plus 2, another k plus 2, because k plus 2 is common. Take 1, then take the outside one, k plus 2. So next step, so k plus 2 is k plus 2 square, because this k plus 2 is k plus 2 square, like that. So now change everything to the form of k plus 1. So change it to the form k plus 1. So this will becomes k plus 1 plus 1, everything square. That is this k plus 2. So because 1 plus 1 is 2. So remember we said we are proving for when n equals k plus 1. So replace all the k plus 1 here. So we are going to get 1 cube plus 2 cube plus 3 cube plus n cube, because this k plus 1 is n now, n cube, so it will be equals to 1 over 4, then k plus 1, that is n square, brackets another k plus 1, n, so that will be n plus 1 square. So you can see from here we have achieved our question back. So that means the given statement is true for n is equals to k plus 1. So far we have achieved that. So the given statement is true for n equals to k plus 1, like that. So therefore Therefore, 1 cube plus 2 cube plus 3 cube plus n cube is equals to this, where n is a member of natural number, is true by P.M.I. That is by principle of mathematical induction. So we have proof now.